Hello everyone, welcome back. In this video, we'll be discussing about the third problem of today's weekly contest, remove nodes from linked list. The problem is very standard. I think you might have seen this in a lot of other, seen some variant of this in a lot of other places as well. So we will just quickly go through it, and I would strongly encourage you to code this yourself without looking at anyone else's code, because this linked list has some edge cases as well. So I would strongly encourage you to code it yourself first, and then look at, if you are not able to do that altogether, then look at the code of others, right? So let's say this is our given linked list, right? So you need to remove, or what the problem states, that you have to remove every node which have a value which is strictly greater value than anything on the right side. For example, uh, in this particular case, for 5 5 there is a value 13 which is greater than 5, so this 5 should be removed. For 2, this is removed. For 13, there is nothing after 13 which is greater than 13, so this will not be removed, so this will stay. For 3, there are nodes which are greater than 3, so this will be removed. For 8, again there is a node after 8, 9, which is greater than 9, so this is removed. And finally 9 will there, so the final linked list would contain 13 and 9, right? So that's the problem. Now how to solve this? First thing could be, like, for every node you can just iterate over the entire linked list starting from there, figure out what is the maximum value, and then decide whether to remove it or not. So for every node you will be iterating over the linked list, figuring out what is the maximum value, right? And then decide what, whether you have to remove this or not. So because number of node is 10 to the power 5, this iteration can require order and time, right? And there are total n such node which, for which you have to do this iteration. So this is order n square. So every time, like, you got a linked list question, just think of it in terms of array if you find it difficult. So for those who know the solution already, uh, it might be overkill, the solution, the explanation, but I'm targeting the people who don't know how to solve this, because for those who know the linked list, it is fairly easy problem. So whenever this kind of question comes in linked list, the first motive of you always should be to solve the problem if this linked list is not there, but we have been given an array with these elements and you have to solve the exact same problem, right? So let's forget about this edges altogether, and let's say this is the array we are given, and we have to just solve for the same problem, like what is the number of elements which are remaining if this is an array. Okay, now if this is an array, you need to just figure out, for 5 what you need what is the maximum value after 5, right? What is the maximum value in this range, right? Can you get the, and for 2, what you will find the maximum value in this range, right? For 13, what you will do, you will find the maximum value in this range, right? So can you see the pattern here? This is, you want something in the suffix, right? You want something in the suffix, so that's where you can solve this problem easily if this is an array with a suffix maximum. So you will just create a suffix maximum which will, like, the value at ith index, let's say the value at here would denote what is the maximum value in this particular piece of the array. Similarly, value at here would denote what is the maximum value in this particular piece of the array. Okay, so what will be the value at here? Value at here would be whatever the value at here, and just consider this extra element, right? So this value already considered all the element, and you know what is the maximum value here, and you want to find out what is the maximum value up till here, so you just need to add one more element to your working set, right? So maximum in this particular piece is 13. So what is the maximum in this entire piece, like, after getting to maximum of 2 and 13? So that would be the maximum value, right? So the value here would be, or suffix of I would be maximum of suffix of I plus 1 and array of I, right? So that would be the value at suffix of I. So hope you got this picture, what, how we are calculating the suffix sum, right? Suffix maximum. Now once you have suffix maximum, you can, for every element, you can just look at the suffix maximum and just figure out what whether you have to remove this element or not. So let's just quickly build the suffix maximum. So suffix maximum would be 9, maximum of 9 and 8, which is 9, maximum of 9 and 3, 9, 9 and 13, 13, 13 2, 13, and 13 5, 13, right? So now let's say we have to decide whether to remove this or not. So can we, we let's say for 5, will 5 be removed? Look at this 13. 13 is greater than 5. Yes, it will be removed. Will 2 be removed? There is 13, so 2 will be removed. Will 13 be removed? There is 9. So 9 is not greater than 13, so this will not be removed. Will 3 be removed? 9. Yes, 3 will be removed. 8 will be removed? Yes, 9 is there after it, so 8 will be removed. Will 9 be removed? No, because after this there is nothing, so you can just consider it as 0 or minus infinity. So 9 will not be removed, right? So that's the thing you will do if you have been given an array, right? But you have been given a linked list, so you can't actually iterate from the backward, right? So if you think about it, I just talked about iterating from backward, right? So what you can do, you can simply reverse this linked list, right? You have to iterate from backwards to calculate this suffix, right? Suffix maximum. So inst like you can't iterate from backward easily. So let's just reverse the linked list. Reversing the linked list is very standard problem. I am expecting that you know that already. If you don't, just Google it and you will get plenty of articles there. Once you reverse the linked list, you can simply find out the suffix maximum, right? Now, once you have this suffix maximum, once you build the suffix maximum for your linked list, you can again reverse the linked list to get the entire, like to get this original linked list. So first we reverse the linked list and then calculate the suffix maximum, right? Then we again reverse the linked list to get the original linked list, right? Now, once we get the original linked list, we will have suffix maximum as well and original linked list as well. So what we can do, we can just simply again consider or compare the next elements and decide whether to remove it or not, right? So hope this entire process makes sense. I am not showing you the code deliberately. The reason being, I want the viewers to try it yourself. I can paste the sample code in the comment section below, but I will not be doing that in next 24 hours because I would strongly want every one of you who don't understand how to solve this problem to try it yourself, because this is not that hard problem. But if you're facing difficulty with this, it might make sense for you to just try it yourself for next 10 minutes or so. Okay, so hope you got the solution. If you have any doubts in the problem, please post them in the comment section below. I would be happy to answer. If you like the video, give it a thumbs up and do subscribe to the channel if you haven't already. I will see you in the next one. Thank you.